Hello there, Mr. Sutton bringing you the AB Calculus 6-7 Extra Practice Number 4 solutions on total distance. For this problem, I have some particle moving along the x-axis with a velocity given by this v function, and this happens on time 0 to 2. So there's some time that we're calling b, at which the particle changes from left to right specifically. We want the total distance traveled during the interval from 0 to the time when this happens. So we need to find the left to right time first, and then we can do something with it to find that total distance. So to find that left to right time, I need to figure out when v is changing from negative to positive. So for that, I am going to use my graphing calculator. So here's my graphing calculator, y equals, and in y1 I've put my velocity function right here. So I want to graph this out, and again, I'm seeing where it crosses from negative to positive territory. But I need a window, so I'm going to use the window they gave me in the beginning here, this 0 to 2 window, and hopefully that sheds some light on this. So window will go 0 down to 2, and let me do zoom 0, zoom fit, and let's see what we're looking at. So here's my velocity function. Again, I'm looking for negative to positive, and it looks like that's happening all the way out here, pretty close to 2. So let me do second trace, option 2 for 0. And then let me move my spider over there and figure out that x crossing. So click a little bit to the left, enter a little bit to the right, enter one more time, and that is about 1.845 and some change. So there's my picture, there's my b value, and I'm actually going to store that on my calculator as well so I can use it again. So let me just quit out of here, and I'm going to, let me quit out, there we go, and then we do store. And I'm going to do alpha b, enter. So now I can pull that back up whenever I need to. So what am I going to use this for? If I want the total distance traveled by the particle from 0 to b, all I really need to do is take the integral of the absolute value of velocity from 0 to b. So it's going to look something like this, integral from 0 to b, absolute value of velocity dt. And back on the calculator, let me do that now. So that's going to be, let's see here, math 9 for integral. We're going 0 to, we did alpha b, and then I'm going to do absolute value, so I'll do alpha window, pull up the abs there, and in here I'm going to put alpha trace y1, and then let me do dx, and all of this comes out to approximately, shouldn't take that long, 1.011, and that's going to be choice C. For this no calculator problem, we have a particle moving along the x-axis with a position given by x of t here, and we want the total distance traveled by our particle over the interval from 0 to 5. So in order to figure this out, the important question here is, am I changing directions at any given time? Because otherwise, I could just take the position at time 5 and subtract from that the position at time 0, and this would be a relatively quick and painless problem. So let's go ahead and take the derivative of this thing just to see if there are any direction changes. So that'll give me the velocity. So that'll be, let's see here, 3 times 2, so 6t squared. This is x prime, also known as velocity that I'm coming up with now. Plus, we've got 6t minus 36. I'm going to set all of that equal to 0 and check for direction changes. And no calculator, so I'm going to do this by hand. I can factor out a 6, leaving me with t squared plus t minus 6. And now doing a little more factoring, things that multiply to negative 6 and add up to 1, we're going to have t minus 2 and t plus 3, which gives me critical values of 2 and negative 3. So I don't really care about negative 3 because they did say time greater than or equal to 0, so we'll just forget about that one. But I do need to look at 2 to see if we have a direction change there. So let me set up a little number line. This is an x prime or a v number line. Again, we're starting at 0, and then we have this critical value of 2 to worry about, and also 5, I guess, because they said 0 to 5, so we don't really want to go past that. But we have a 2 in the middle. So now testing something on each interval, let's test out 1 on this first interval, and I'm just using this factored version of x prime here. So that's going to be a positive times, 1 minus 2 is a negative, times a positive. 1 negative gives me a negative overall. And now between 2 and 5, let's test 3. So that's going to be a positive, 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 which comes out positive. So we do have a direction change at x equals 2, or t equals 2 rather, because x is actually the output in this function. Okay, well that means that I need to calculate the distance between times 0 and 2, the positions at times 0 and 2, and I need to take the absolute value of that distance, and then I need to add to that the absolute value of the distance at times 2 and 5. So my setup then, I have absolute value of x2 minus x0 plus absolute value of x of 5 minus x of 2. So I'm going to calculate what x of 0, 2, and 5 all are, and then I'll plug it back in here. X of 0 is definitely the easiest one. That zeroes out all the t values, leaving us with just 50. X of 2 has a little more work involved. We've got 2 plugged into all those things. So this is going to be, let's see, 16 plus, this is going to be 12, so that's 28. But now we're subtracting, well, let me add 50. So that's 78. Now we're subtracting 72, so that's a total of 6. Okay, I guess that could have been worse. And now we need x of 5, plugging 5 into all these things. Oof. Well, here we go. So we've got, this is 5 cubed is 125 times 2 is 250. So we have 250. I'm going to add the 50 over here. That's 300. We've also got 3 times 25, so that's 375 total. 375 minus 180. That's going to come out to 195. Cool. All right. So I've got then x of 2, which is 6, minus x of 0, which was 50. So 6 minus 50 plus, and that was an absolute value, plus now we have 195 minus 6. And what does all this add up to? So over here, this is going to be 44. This is going to be 189. Let's see here. 189 plus 4 is 193, plus another 40 is going to be 233. So that gives us choice D. For this problem, we have a particle moving along the x-axis with this velocity function. And if the particle is at x equals pi at time 0, which gives the position of the particle at time 4. So we're going to go through each of these and see if they line up with what we expect for this. So this first one here, integral of velocity basically, that's giving us the displacement. Now displacement is an important piece of finding the position, but just telling you the change in position by itself is not going to tell you the new position. You kind of also have to know where you started to go with that change in position. So displacement is not quite the same as position. This next one now, we have pi, which happens to be the starting x value, plus basically what they gave us in A, plus the displacement. Well, if you have your starting position plus the change in position, that will give you the new position at whatever time you want. So this is a yes. And we could probably pick this, but let's just look at the other ones to really be on the safe side here. So this next one, we're taking the derivative of velocity at time 4. Well, that's just the acceleration at time 4, so that's a no. And for this next one, we're taking the absolute value of the velocity from 0 to 4. That's going to give us the total distance traveled from 0 to 4, which is not the same as the position, obviously. So that's also a no. So then at the end, choice B is the best answer. On this one, over the interval 0 to 10, we have a particle moving along the x-axis. Graph of its velocity is given above. Now, over this time interval, they're telling us the displacement was 15 and the total distance traveled was 73. Based off that, they want the total distance the particle travels while moving to the left. So I'm going to think about this problem in terms of distance moving left and distance moving to the right. So I'll let r be my right moving distance, which is going to be a positive number, and L, also a positive number, is just my absolute left moving distance. So I'm going to set up 2 equations involving right and left. One's going to have the displacement as the focal point, and for the other I'm going to talk about the total distance in terms of these quantities. Now when I'm doing this, it's helpful to know which one of these is bigger. Since my displacement is positive, I know that r is greater than L, so that's going to help when I'm trying to do subtractions and things like that. So setting up my 2 equations, the displacement is basically the total distance in the positive direction minus the distance in the negative direction. So we're going to have basically r minus L, in this case, equals 15. And for total distance, we're actually taking r and l and adding those together. So that would give us r plus l equals 73. So we have displacement versus total distance. In one, the distances are working against each other. In one, they're working together. This actually gives me a system of equations I can now solve. In fact, this would be a very quick one to solve if I just added these equations together. That would cancel out these l's, leaving me with, if I add these, 2r equals, this would be 88. So that means that my right moving distance has to be 44. Well, they wanted to know the left moving distance. So let me go back and plug this into one of these equations that I can use to then solve for the left moving distance. I'm going to go the one that has all positives in it. So I'm going to do 44 plus L equals 73. So then subtracting 44 from both sides, that is going to be 29 for L, which gives us choice B. For this problem, we have velocity of a particle along the x-axis given by v of t. And we want to know which gives the total distance traveled by the particle over this interval. So this is kind of an interesting problem because they don't want like a real answer. They just sort of want the setup for this. And some of these look kind of similar. So in general, total distance, if you're starting with velocity, the only way to get it is with some kind of integral. But our two answer choices, well, we have three answer choices with integrals in them. So we're going to have to narrow this down a little bit. Now, you'll notice that in one of these choices, there's only a single integral, while in the other two integral choices, we have two integrals. So the big question here is, do we have a direction change sometime between times 0 and 3? Because if we don't, then we just need one integral like in choice C. If there is a direction change, then we need two integrals, and one of them is probably going to be negative velocity, so we're going to have to make one of these integrals negative to offset the fact that it's already negative. So let's take a look at velocity and see if that changes sign anywhere. Let me start by setting that equal to 0 and solving. If I add 1 to both sides and then take the ln of both sides, I can write t minus 1 equals 0. So then t has a value of 1. Now this doesn't prove anything, just that we have a critical value, a possible sign change at 1, which, I mean, taking a look at the answer choices, that is where they're breaking up these two integrals in choices B and D. So far, this is kind of squaring with what we see in the answer choices. But do we change sign there? So let's set up a number line. This is a V line. And let's see here. We're going from 0 to 3 for the endpoints. And we have that critical value of 1. So a number between 0 and 1. Let me try 1/2. Now I'm plugging this into the V function here. So this is going to be e to the 1/2 minus 1. That's e to the negative 1/2. That's 1 over the square root of e. Well, since I'm dividing 1 by a number that's bigger than 1, the square root of e is still bigger than 1 because e is bigger than 1. So I've basically got something smaller than 1 for this e term here. If I subtract 1 from that, I'm going to get a negative overall result. Now something between 1 and 3, 2 seems pretty easy. In that case, I've just got e to the 2 minus 1 minus 1. That's just e minus 1. We know e is 2 point something, so that's going to come out positive. So at this point, this is telling me what kind of integrals I'm going to need to get the total distance. In this interval from 0 to 1, because I'm moving in the negative direction, I'm going to have to make that whole integral negative. So I'm going to need a negative integral from 0 to 1 of v of t dt. And this next integral from 1 to 3, that's already positive movement there. So I'm just going to add that integral because everything's already going to come out positive there. So plus the integral from 1 to 3 of v of t dt. And that is going to match answer choice D. For this problem, we have Gwen running back and forth along a straight track, and during the time from 0 to 45 seconds, her velocity is modeled by this v of t function. And again, this is a calculator problem, so I'm really glad because this looks kind of nasty to deal without a calculator with. So now our first task is we want to know the first time, which they are making us call t1, that Gwen changes directions. And then they want her average velocity over the interval from 0 to that first direction change. Okay, well, to figure out the first time she changes directions, I need to take a look at the v function and see where v of t first changes sign. So for that, let me use the grapher. So I'm in my y equals now. In y1, I've entered the velocity function for Gwen, and boy, was that a doozy. I had to use 2 levels of fancy fraction mode with alpha y equals n over d mode, but we're here now, so I need to graph this thing out. I'm going to use the window from 0 to 45 because that's when Gwen is doing her thing there. So let me do window 0 to 45 for x min and x max, and then zoom 0, zoom fit, and let's take a look at Gwen's velocity. So she starts off running forward, then, well, not backward, but in the other direction, and she keeps running back and forth, we see. And this looks kind of like one of those, like a reverse suicide sort of run. She runs bigger distances at first, or at least she's faster at first, and then, well, whatever. Let's just get back to the problem. So her first sign change happens right here at this spot. Let me do second trace and then option 2, 0 to figure out what spot that is. I'm going to move my spider a little bit to the left and press enter. A little bit to the right, press enter again. Press enter a third time for good measure. And then that's going to be about 19.416, and that's going to be in seconds. So that is T1. That's the value of T1 right there. And now we want the average velocity from 0 to T1. So let me go back to my calculator, actually, and I'm going to quit out, and I'm going to store what I just got for T1. I'm going to store that as, they want me to use, I'm going to use A, alpha A. There we go. Okay, so to find the average velocity, I basically need to use my average value set up on velocity. So I'm going to have 1 over the interval. That's going to be 1 over T1 minus 0. And I'm allowed to write that because I just told you what T1 is. It's this number right here. So now I can use T1 instead of this number everywhere else in the problem. And let's see, I'm multiplying that now by the integral from 0 to T1 of, well, we're going to have to just do the velocity, right? We're taking the average velocity, so v of t dt. And they already told us what v of t is, so I'm not going to rewrite it. But I am going to do this on the calculator. So here's what this looks like on my calculator. Remember, I stored my T1 value as an A on the calculator, so I have 1 over A minus 0. Math 9 got me my integral, so integral from 0 to A. And then I did alpha trace to pull up the Y menu and pull Y1 out of that. So now pressing enter, and this is going to be average velocity. So this is going to be 7.264, and that is going to be in velocity units. So that's going to be, let's see here, feet per second is what our units are. Feet per second. For this part, they want to know at time 45, how far is Gwen from her position at time 0. So basically we're asking for Gwen's displacement, which is just going to be the integral from 0 to 45 of her velocity, v of t dt. So let's just plug that in the calculator. So here's the setup on my calculator. Again, I entered v as my y1, so that saves me the trouble of rewriting it. And then I just press enter, and her displacement, which is going to be measured in feet, is 116.538. Again, feet. For this next part, they want total distance Gwen runs during 45 seconds. So this is going to be another integral from 0 to 45, but this time we're taking the absolute value of velocity, so absolute value of v of t dt. And I defined what v is. Absolute value is just using this function that's already defined. So I really can just write this and then plug it in the calculator. So I started this off on my calculator, and just one thing I wanted to show you if you forgot how to get to it. The absolute value function, if you do alpha window and then just pick the first option there, abs, that'll get you your absolute value. Then I can just do alpha trace and then press enter for the y1 there. And then go over and let's do dx, press enter. And now her total distance traveled is going to end up being, and again, this is going to be in feet. It's taking a while. Run faster, Gwen. Dramatic drum roll. It's all that back and forth running. It has to take each area separately. Wait for it. Wait for it. Maybe I could sing some karaoke while we're waiting. Man, this really is taking all day, isn't it? Don't stop believing. Keep on calculating. Oh, there it is. 250.099. All right, we made it. For the final part of this problem, A of t is Gwen's acceleration from 0 to 45 seconds. They want us to find the value of the integral from 15 to 30 of A of t dt, and then tell us what it actually means. Okay, so this is really taking the integral from 15 to 30 of v prime of t dt. It's another way we could think about it, since acceleration is the derivative of velocity. So if we think about it like this, taking this derivative, even though they didn't define acceleration, we just need to figure out what I had to take the derivative of to get acceleration if I want the antiderivative of it. And the antiderivative of acceleration is just going to be v. So we're just evaluating v from 15 to 30, which is pretty easy because we already have the v function in our calculator. So this is just going to be v of 30 minus v of 15, which let me do that on the calculator now. So to do that, I have my v function stored as y1. So I just did alpha trace y1 parentheses 30, and the same thing with parentheses 15, equals negative 4.844. Now the units on these are going to be in terms of velocity. I'm doing velocity minus velocity. So this is going to be feet per second units. And what did we actually just figure out here? Well, what did we just take the integral of? We took the integral of the rate of change of velocity. So that's going to give us the total change in velocity from 15 to 30 seconds. And that's going to be in feet per seconds, like we put up there.